Hello, grade sevens. I hope you had a lovely weekend. The weather was so nice. I hope you spent some time outside. We are almost finished with our unit on area and measurement. So we at the beginning of the unit, we did converting measurement units. So we were converting, for example, from centimeters to meters or millimeters to centimeters, for example. And you're still going to be doing that a little bit in area. And then we looked at area of a bunch of different figures. And let's go over those formulas really quickly. So we know that area of a rectangle is length times width. We know the area of a triangle is base times height divided by 2. We know the area of a parallelogram is equal to base times height. And we know the area of a trapezoid is equal to height times base 1 plus base 2 divided by 2. Okay, so those are important formulas to know, and the more you use them, the more likely you'll be to memorize them. Especially area of a rectangle and area of a triangle are ones that you'll use quite often, but even parallelogram and trapezoid are good to memorize. Okay, so now that we know those things, you know how to find the area of all of those shapes. What if you have a shape that's not any of those things? What if you have something that's a combination of those things? So for example, what if you had this? It's not a rectangle, it's not any of those shapes, but you could split it up into 2 rectangles. So what you can do is find the area of this part of the shape and the area of this part of the shape and add them together, and you'll have the area of the whole shape. So let's look at it. So what if we are told, okay, this is 1 meter, that's 0.7 meters, this is 1.6 meters, and this is 0.5 meters. Well, what are we missing? We're missing this side, and we're missing this side. So we don't necessarily need to know those parts, but let's find them in case we do. And how will we find them? So how will we know what that is without measuring? We can't measure because this is not a accurate drawing. It's not a proportional drawing. That's not really 1.6 meters, is it? So let's think. We know what this is. So this part of it should be the same size as that, right? So that would be 1.6 here. And this part would be the same as that, which is 0.7. So the whole thing will be 2.3 meters. Okay? So what we can do now that we have that is, we actually need to find this part as well. So the whole thing is 1 meter. This part is 0.5, which is the same as here. So this part is also 0.5 of a meter. And I haven't drawn this accurately enough. It doesn't look like 0.5, but we'll write that in there, 0.5 meters. So what you can do now is find the area of figure A and the area of figure B, okay? So the area of A is equal length times width because it's a rectangle, and then we plug in our numbers. So 1 meter times 0.7 of a meter, okay? So now we have 0.7 meters squared, okay? Then we'll find this part of the area. So area of B, length times width again, which is 1.6 meters times 0.5 meters. So let's try that over here. So 16 is 5, 30 times 5 plus 8, okay? And then we count in our decimals there. So that equals 0.8 meters squared. So now we have that our area of figure A is 0.7 meters squared and area of B is 0.8 meters squared. So let's add those two together over here. So 0.7 meters squared plus 0.8 meters squared equals 1.5 meters squared. So the area of this whole composite shape is 1.5 meters squared. Okay, so let's try the next one here. Just erase that one so we can get that out of the way. Okay, so again, we have a composite shape where the whole shape isn't anything in particular, but we could split it up and have a rectangle here and a rectangle here. Now, the only problem here is that we are missing some of the measurements. So this part's 1 meter, so that means that this part is 1 meter here. This part is 1 meter. This across here is 1.2 meters. Down here is 0.8 meters. So that means if this is 1.2 meters, that means this is 1.2, which means that whole length across the bottom is 2.2 meters. Okay, now how could we find what this side is? Can you see what we would add together to get that measurement? So if you imagine that line goes over here, this is going to be 0.8 and 1. So this whole measurement over here is 1.8 meters. Okay, so now we want to find the area of figure A and figure B. So the area of A equals length times width because it's a rectangle. Now there's a lot of numbers there. We don't need all of them. So let's see what we need. So we need the length here and the width. So we want to make sure we don't use 2.2 meters because that's the whole base, and we're just going to this part, which is 1 meter. So 1.8 times 1, which is 1.8 meters squared for figure A. Now for figure B, length times width again because it's a rectangle. So not 2.2, we're going to use the 1.2 for the length, and the width is 0.8 meters. Okay, so we'll multiply those. So 1.8 times 1.2 times 0.8, so 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. And then we count how many numbers are after the decimal, so 1, 2. So we move the decimal in 2 places, 1, 2. So 0.96 meters squared for figure B. Now we have to add, for the whole area of the whole shape, we have to add the area of B plus the area of A, which is 0.96 plus 1.8, which is, let's put this over here, 1.8. Now, tell me what I'm doing wrong here. What is the problem there? I have not lined up my decimals. So it looks tempting to line up the numbers based on how many digits we have, but we have to line up based on the decimals, so like this. So we're going to add these together. It might be nice to put a 0 here because as a placeholder, and we could put a 0 here if we want to. So 6 plus 0, 6, 17, carry the 1, and 2. 2.76 meters squared is our area for this whole figure over here. Okay, so I'm going to erase that, and then I'm going to try another one. Now those were quite nice because it was easy to see where the rectangles were because I already drew the line. What if we had a shape where you can't see any particular shapes within it, okay? So, for example, like this. I'm going to erase the bottom part here a little bit to try to make this look more even. Okay, so let's say this is 5 meters across the top, and then this is 1 meter, that's 1 meter, this is 4 meters, and this is 3 meters. This is not very accurate. Of course, it's not meters, but even the numbers aren't very accurate, but let's go with it. Okay, so what do we do? So first, let's try to find some of the measurements that we're missing. So we know this other side's 4 meters too, because this one is. This is 5, that's 1, and that's 1. What would this one be? So what we have to do to find that out is imagine this is that part of that, right, to there. That is that, so we've got one here and one here. If the whole thing is 5, and these parts are 1 each, what is this part? That would be 3 meters, right? And then this is also going to be 3 meters on the other side. So we don't have a formula to find this exact shape. So what we have to do is cut it up so that we can figure out, cut it up into shapes that we do know, okay? So let's look and see. So, I mean, you could do some triangles, but that does not sound like fun to me. The simplest thing to do would be to cut it into rectangles. And you have a few choices here. So you could cut it up like this, and then you'd have 2 long rectangles and a narrower one, or you could cut it here, so you have 1 long one that way. I'm going to try it this way. Now, do you think it matters which way you cut it? No. You will get different answers for the figures, but you will get the same final answer, so it doesn't matter. So let's call these A, B, and C. And you know what? The nice thing about A and B is that they're going to equal the exact same thing. So once you find the area of figure A, you can multiply that by 2, and you'll have those 2 done. So let's try this. So area of A is length times width because it's a rectangle, and that is 4 by 1. So that's nice and easy. So that's 4 meters squared. And let's just do area of C right away, and we know that's 4 meters squared as well because it's the exact same shape as A. So now we just need to find out area of B. That's length times width because it's a rectangle. And let's see, what is it? So we have something here that we're not sure about. So we know that the length here is 3 meters. But how long is this part? We know this whole thing is 4 meters, and we know this part is 3. So what is that? So if the whole thing's 4, and that part of it is 3, that means this is 1. So 3 times 1, which is 3. So now we add these 3 areas together. So we have area for figure A is 4, C is 4, and B is 3. So we have to add area of A plus area of B plus area of C equals 4 plus 3, which is 11 meters squared. Excuse me. So that is how you find out an area of a composite figure that you don't have a formula for. You cut it into shapes that you do know, find those areas, and then put them together. Okay, so quickly, well, it's not very quickly because this video is getting a little long, but I want to make sure you understand this before we wrap it up because you're going to have your final assignment, and we're not doing a test exactly, but I'm going to give you an assignment that you have 2 days to do, and I want you to know exactly what to do before I assign you that. So let's try one more problem here. So let's say we had a nice rectangle. So that looks great. We know how to find this, and it's actually a square because because we see that the length and the width are the same. So that's really easy. That's nice, isn't it? So we know that's length times width, which is 3 times 3, which is 9 meters squared. So that's nice. But what if you had a square in the middle here, a square cutout, and it was 1 meter by 1 meter? So that part is missing. So now, oh no, we want to find this part, but not that part. So let's think, what could we do? Well, we could find, let's do this. You could find the area of this part. You could find the area of that part. You could find that, you could find that. You can add them all together. But you know what? There's an easier way. What you can do is find the area of the part that's missing and just take that away from what it would be if you didn't have that hole in it. So instead of finding all these areas, find out what you're missing and subtract that from your total. So what is the area of that missing hole? That is length times width, which is 1 times 1, 1 meter squared. So if the whole shape is 9 meters squared and the missing part is, excuse me, is 1 meter squared, we can subtract that from 9 meters squared minus 1 meter squared, and we will get 8 meters squared. So we don't have to find all these little parts and add them together. We know if we take that away, we will find what is left here. So it's 8 meters squared. So that's much easier. Now, what if we had the same shape, but the hole, and the hole is the same shape as well, but the hole was in a different spot? What if it was over here? And it was still 1 meter each, 1 meter by 1 meter. Would that change anything? So again, we would find the area of that, which is 1 by 1, so it's still 1. So, and we subtract that from 9 meters squared, because 3 times 3 is 9. You're still going to get 9 minus 1 is 8 meters squared. So, no matter where that hole is, as long as it's inside that shape, it doesn't matter. You just need to find the area of the whole shape and subtract the part that's missing, whether the hole is there or whether it's here. If you only have that one shape, then you can figure that out. It doesn't matter where the placement is. Okay, so let's erase this, and I'll tell you about your assignment that you're working on. Okay, so this is wrapping up our unit that we've been doing online on area and measurement. Okay, so it's on page 186 to 187, so it's the work from your book. What I want you to do is number 1, 2, 5, and 6. This is due Tuesday, tomorrow, at 5 p.m. And if it's late, points will be deducted if late. Okay, so it needs to be in Tuesday at 5 p.m. Here's the assignment. So this is your final assignment. So instead of having a test, we are having a final assignment. So there won't be a video tomorrow. So this is the video for Monday and for Tuesday, and you can work on these over the 2 days. You are allowed to use a calculator. Your parents can help you and check over your work before you send it in. You can email me if you have questions. So I want you to do well on this, and I think you will. You guys have been doing well on this unit. So we just want to wrap this up well and move on to our next unit. So let me know if you have any questions, and have a great day.